Hello students, today we are going to discuss about a topic which is our projectile motion. First of all, let's start discussing what is a projectile, okay? Projectile is anything which we throw in a plane such that it is applied by an acceleration in one of the axes. Say for example, I'll take a basic example that we have a ball and the ball is thrown like this with some velocity. Obviously, this ball will go high up inside the air, and as we all of have seen that whenever we throw a ball, it follows the path like this. So the thing which we have thrown, this thing is called as projectile. It is called as projectile, and the motion of this thing through which it passes, studying the motion, this motion is called as projectile motion. So in a projectile, there is a one fundamental thing which we need to understand, and that is there must be acceleration in one of the axes. For example, this is the quite important condition for the projectile, that there is acceleration in one axis. Either it can be x-axis or it can be y-axis. Since the projectile is a thing which is fired, which is thrown in a plane, we all of know that in a plane we have two axes. We can choose any of the two. We can name them by whatever is convenient to us. So for example, I name these two axes as x-axis and another one as y-axis. I have taken the horizontal axis as x-axis and the vertical axis as y-axis, okay? Now, as we can see that when I throw this ball up in the air, I can see that the vertical axis is there and the horizontal axis is also there. So we have a vertical and horizontal axis. Fine. Now, we all of know that in the horizontal line, when the ball is somewhere at the position, at any random position, the projectile is somewhere at any arbitrary or any position somewhere in the air, in the plane. If I ask you what is the axis, if I ask you in which axis there will be the acceleration on this ball and in which axis there will be no acceleration on this ball, okay? Well, all of us know that the ball is attracted by the gravity. The ball is attracted by the earth, the gravitational pull of the earth. So in this axis, in one of the axes which we call as x-axis, there is acceleration. We all know that that is called as acceleration due to gravity, and it has a value of around 9.8 meters per second square. Approximately, we say we take it as 10 meters per second square. But if I ask you what is the acceleration in the x-axis, can anybody tell me what is the acceleration in the x-axis? Well, we see in the x-axis like this, we do not find any of the forces. Yeah, you can say, sir, there can be the drag force which is caused by the winds, or there can be some opposing force due to air drag or air friction. Well, that can be there, but we neglect those minimum forces, because the force which the earth sets up, or the earth with which the earth pulls this ball, is much greater than the drag which is offered by the winds or the air, okay? So we here take one more condition, that air drag is absent. There is no air drag. So there is no air drag. When there is no air drag, that means the acceleration in the x-axis, it is zero. There is no acceleration in the x-axis. So we can assume that in the x-axis, the body can move, or the body is moving with uniform motion, and in the y-axis, the body has got an acceleration. Body has the acceleration due to gravity. It is applied by some force, that is the force of gravity here. So we say in the x-axis, there is no acceleration. So in the x-axis, acceleration is 0, and in the y-axis, acceleration is there. That is the acceleration due to gravity. Okay. So, well, we take these two as the key points to study the projectile motion. So what we understand till now is projectile is anything that's fired in a plane that can move in a plane, means that can move in two axes, x-axis and y-axis, or any of the two, whatever is convenient to us. But at the same time, there is the acceleration in one of the axes. There must be the acceleration in one of the axes, and the another axis can have zero acceleration. So the best example of these projectile motions are when a batsman hits the ball goes through the boundary, the ball goes up in the air. So there is always the acceleration downwards towards the earth. And in the x-axis, if we assume there is no drag, there is no acceleration, so that kind of motion of the ball when the batsman hits the ball, that is called as projectile motion. Or you can also say, now, when we have understood that what the projectile is, and we are going to study the motion of that projectile. So there are always some basic terminology related to any topic. So let's first of all discuss those topics, those terms which are included in this topic. The terms which are included in this topic, I will write down those. First term which we will encounter during this topic is, that is time of flight. We denote it with capital T, okay? As it's evident from the word, that time of flight. Time of flight must be the time for which the body remains flying in the air, or the body remains in a plane, moving in a plane, okay? Second term, which we have to study here is, that's called as point of projection. This is called as the point of projection, because the projectile is projected from this point. So we call this as point of projection. There's also one more important point where the ball finally lands, and this is called as the point of landing. Point of landing. So we can say the time through which, for which the body remains in air from the point of projection to the point of landing, that time interval is called as the time of flight. So the time during which the body remains in air from the point of projection to the point of landing, that time interval is called as the time of flight. So one more term which will come here is the velocity of projection. We denote it with small u. So second term related here is, that's called as velocity of projection. We also call it by one more name, that's called as initial velocity of projectile. It is the initial velocity of projectile. Okay. So we here will find that this u with which the body is initially fired, this is called as initial velocity of the projectile. Whatever the velocity may be, it may be 10, 20, 30 meters per second, anything, that velocity is called as velocity of projectile, or the initial velocity of projectile. Why initial? Because it is the velocity which is at the point of projection. And now we can also argue by saying that, sir, if this value is say 5 meters per second, is it possible that the ball will also have the same velocity somewhere else? No. Ball cannot have the same velocity always, everywhere. That's why we call it as initial. Why initial? Because it is the value of the velocity when it is projected initially from the point of projection. Okay, this is the next term. And now the third term which will be associated with this is that we called as maximum height of projectile. Maximum height, and we may represent it with h max. It is the maximum height, and it will be evident to you from the diagram that maximum height is always the height of the body from the ground, but it should be the maximum one. So this can be the maximum height of the body from the ground. And you can also look from the diagram that if I see body somewhere else, the height is not maximum. If I see the body somewhere else, the height is not maximum. The height is maximum only at one particular point, and that one particular point here is this. This is that one particular point where the body is located. And this height of the body from the ground, this height is called as the maximum height of the projectile. Okay. Now, one more term which is associated here, that is called as range of the projectile. That's called as range of the projectile, and we represent it with capital R. Okay. Now, what is the range? As we studied maximum height, but let me tell you, this maximum height is the height, or it's the displacement of the body from the ground, maximum displacement. Okay. But this displacement is in y-axis. Okay. So this displacement which we can see, it is in y-axis, as you can also see like this. It is taking place in y-axis. Okay. But when we throw a ball, when we project a projectile from the point of projection to the point of landing, there is also one of the distance which is in the x-axis, that we can call as this, that I can show with the red mark like this. This distance, horizontal distance, remember, this is the horizontal distance from the point of projectile, from the point of projection to the point of landing. This horizontal distance, we call it as range. We call it as range. So what is a range? Range is the horizontal distance from the point of projection to the point of landing. This is called as range. Okay. So these are the terms which are associated with this topic, that is the topic of projectile motion. And there can be one more term also which we can relate to this, and that is called as trajectory. That is called as trajectory, and it's a very important term. What is a trajectory? In simple language, I can say trajectory is nothing but the path of the projectile. It is nothing but the path of the projectile. So what is actually the path? When we have thrown this ball, say from the point of projection to the point of landing, it was moving high up in the air, but there is certainly a path. There is certainly a path through which the body has traveled in real. So if I say the body was somewhere here and the body reached somewhere here, but there will always be a question, sir, through which path the body has reached? What is the actual path? What has been the actual path of the body? So has the body directly moved like this, or has the body moved like this, or has the body moved like this? So definitely there is one actual path through which the body has moved, and that one actual path is, I can show you like this. So the actual path through which the body has moved, this is called as trajectory. This is called as trajectory. So throughout the motion of this body, throughout the motion of this projectile, the body has certainly taken up a one certain path, and that one certain path is called as the trajectory of the body. So here I can show the trajectory of the body is this line through which I have drawn it with the green color. So this is the trajectory of the body. So these are the very things which one should be familiar with before studying this projectile motion. So number one is the time of flight. Second, the initial velocity of the projectile. Third one is the maximum height and the range and the trajectory. Okay. So now let's analyze the projectile motion in detail. So the first thing we need to know here is the components of a vector. Whenever we have a vector which is making some angle with any of the axes, say the vector u is making the angle theta with the axis x. So we have studied this, that this vector has a component u cos theta along this axis where it is making the angle theta. Also, the same vector is having a component of u sine theta in the axis which is perpendicular to this one axis. Okay. So if I say there are two axes, number one is x-axis and y-axis. So I say along the x-axis, the vector has a component u cos theta, and along the y-axis, the same vector has a component u sine theta. Okay. Once we are familiar with this vector resolution or the components of the vector, we can easily study or analyze the projectile motion. How it is done? Let's first of all take the angle with the ground which a projectile is making, and this angle here, and this angle here, this is called as angle of projection, okay, or the angle which the initial value of the velocity makes with the ground. This is our ground, okay, this is our ground, and this is the direction in which we have thrown this projectile, okay. So the projectile is supposed to go like this initially, and the ground is like this. So there is an angle which this velocity of the projectile is making with the ground. This is called as the angle of projection. This is the angle of projection. So we can easily make out the components out of this. I can say the vector has an x component like this, and the same vector has y component. I will show the y component in any other color like this. So vector has two components, x component and y component. The x component has a value of u cos theta, and the y component has a value of u sin theta. That comes out from this concept which I told you. It is the vector resolution, which has been already earlier taught to you, okay. Now in the beginning of this projectile motion, in this topic, I said that projectile, when the projectile is flying in an air, so it is applied by acceleration downwards by the gravitational pull of the earth. Anywhere I can see that if I when I have thrown this ball, the ball is applied by some downward acceleration. The ball is applied by some downward acceleration, and that is the acceleration due to gravity, which we call as g, acceleration due to gravity. But in the x-axis there is no air drag. Assume there is no air drag, so there is no acceleration. So what will happen to the components of these velocities? Anywhere we see the ball is having the x component as u cos theta, and it will always remain same. It will never change. So the x component of the ball is never going to change. If I see here, the x component of the ball is never going to change. And why so? Because there is no acceleration in the x-axis. So we say the x component of the ball is always u cos theta. X component of the ball is always u cos theta. And why it is so? Because the x-axis acceleration is 0, but we know that in the y-axis the acceleration is acceleration due to gravity, okay. And what will happen to this y component? What will happen to this red color component, which is trying to move the body upwards, but the earth is trying to pull the body downwards? So what will happen? The body will try to move upwards. The body has a tendency to go upwards. Why upwards? Because it has got the velocity u sin theta upwards. It has got a velocity u sin theta upwards. At the same time, the body is being pulled. The body is being pulled by the gravitational pull of the earth. Gravitational pull of the earth. So the body will not continue to go upwards. Eventually, it will go upwards, but it will try to fall down towards the earth. That's why this path is being followed by the ball. The ball was expected to go like this, but we see the ball is not going linearly like this. It is being fall down towards the ground. Why it is being fall down towards the ground? Because it is applied by the gravitational pull of the earth, okay. So what makes this u sin theta component to fall down? So it becomes weaker and weaker and weaker. So it no longer remains this u sin theta. Say this u sin theta was having the initial value of 10. It will go like this: 10 and 9 and 8 and 7 and 6 and 5 and 4 and 3 and 2. And continuously, when it will reach this point, the y sin, then the u sin theta will eventually become 0. It will be having no component up to this maximum point, okay. It will be having no vertical component up to this maximum point. And now what will happen after that? After that, the gravitational pull of earth will keep on pulling the ball downwards, and this u sin theta, this vertical component, will again become visible. So it will again exist. It will again start existing, and the time will come when the body will hit the ground, and at the ground it will gain all its u sine theta component. And well, we already know that it was having u cos theta in the x-axis without any change, and the u sine theta will again be gained by this body at the point of landing. Okay, so this is the velocity vector analysis of the body. Okay, at anywhere we see that u sine theta, u cos theta is not going to change. But the vertical component of the body, first of all, when the body is going up, the vertical component of the body dies. It becomes smaller and smaller, and at the topmost point, it dies completely. And again, the vertical component of the body, it gains its value again, but now in the downward direction, because the body is being pulled downward by the earth. So it gains again its value, and finally it again revives its value, but in the opposite direction. And we know that initially the time which it takes from this point of projection to this point of landing, that time is called as time of flight. So we can analyze the whole projectile motion to have like it is the one-dimensional motion that is taking place independently in two axes, one of which is x-axis and one of which is y-axis. So this body is just like having independent motion in x-axis as well as y-axis, but there is always one of the connectivity between the two, and that connectivity is the time. When I say the body reaches somewhere here in the x-axis, at the same time I have to say the body has gained the vertical component like this in the same time. Okay, so now let's find out how much time it will take the body to go from this point to this point. So as I say that, this can be well understood by analyzing the body in one axis. So sorry, we have already studied it in the one-dimensional motion, that when a body is thrown up, say with some velocity v, and the body comes back to the same point on the ground, the time taken throughout this motion is twice of v divided by g, 2v by g. Okay, this was already taught in one-dimensional motion. So here also we will use the same fundamentals, but here there is only one change, that v which we were studying in one-dimensional motion, that was the velocity with which the ball was fired upwards, only upward components. Okay, and here when we have to put the value of v, we will not write completely v, we will take this u sine theta as v. Okay, because now this is our vertical component with which the ball is trying to go upwards. Here it was completely upwards, it was not a projectile. The ball was just going up and it was making its path through the same line downwards. But here the body is thrown at some angle of projection. Okay, but the vertical component is still the same, u sine theta or u sine theta. Now I will assume that here in the projectile motion, the ball is now going upwards with u sine theta. Now it is returning back to the ground, but these 2 points are different. These 2 points are different. The ball was going upwards from the point of projection, and now it is coming down at the point of landing. So when we say what is the total time of flight, so we say the total time of flight is twice of v divided by g, but the v should be u sine theta divided by g, and this is our value of 2u sine theta divided by g. This is the value of time of flight of this projectile throughout the motion from the point of projection to the point of landing. This is all about today. So now we will study another